Hi everyone, let's solve this antiderivatives of function. So, find the antiderivatives of the following polynomial function. Oh, this is not polynomial function. This is a rational function. But before that, what are the rules? So, the integral of dx is equal to x plus c. The antiderivatives of x raised to n with respect to x is x raised to n plus 1 over n plus 1. So just simply add 1 to the exponent and then copy that exponent, divide this by that exponent n plus 1 plus c. Next rule, antiderivatives of a f of x with respect to x. So if you have a coefficient, you can write that coefficient before the integral symbol. That will become a antiderivatives of the function with respect to x. So in other words, if we have antiderivatives of a with respect to x, that will become a antiderivatives of dx. So therefore, that will become x. So ax plus c is the answer. Next, the antiderivatives of x raised to negative 1 with respect to x is the same as antiderivatives of 1 over x. So, 1 over x is the derivatives of ln. Therefore, the antiderivatives of 1 over x is ln of x plus c. Okay, so let's now solve the following so that you can understand how to apply these rules. Okay, number 1. What is the antiderivatives of 12x cubed minus 9x squared plus 8x minus 3? Okay. So if we have coefficient, okay, we can distribute also the antiderivative symbol in each term. So this will become antiderivatives of 12x cubed with respect to x minus antiderivatives of 9x squared with respect to x plus antiderivatives of 8x with respect to x minus antiderivatives of 3 with respect to x. Since we have coefficient, okay, we can write that coefficient before the integral symbol. So this will become 12 antiderivatives of x cubed with respect to x minus 9 antiderivatives of x squared with respect to x plus 8 antiderivatives of x with respect to x minus 3 antiderivatives of x. And then, let's apply now the power rule. So, if we're going to find the antiderivatives of this, just simply add to the exponent by 1. So, this will become 12x raised to 4 because 3 plus 1 is 4 and divide also by 4 minus 9. So, this is squared. So, plus 1. So, this will become x cubed over 3. So, 3 plus 8. So, the exponent of x is 1 plus 1. So, that will become x squared over 2 plus, minus here 3. Antiderivative of dx is x plus c. Then simplify. 12 divided by 4. 12 divided by 4, that is 3. So, this will become 3x raised to 4 minus 9 divided by 3. That is 3x cubed plus 8 divided by 2, that is 4x squared minus 3x plus c. And this is now the antiderivatives of this function. Next, number 2. Find the antiderivatives of x squared plus x plus 1 with respect to x. Okay, so let's distribute the antiderivative symbol. So the expression will become Antiderivatives of x squared with respect to x plus antiderivatives of x with respect to x plus antiderivatives of 1 with respect to x. So 1 will become invisible here. Then simplify. So we have x squared of plus 1 will become 3 over 3 plus x. The exponent here is 1 plus 1 is 2. So we have x squared over 2 plus integral of dx is 1 plus c. And this will become and this will be the answer. So this is the antiderivatives of this function. Okay, next, number 3. For number 3, let's distribute the integral symbol. The antiderivatives of 10x raised to 4 with respect to x minus antiderivatives of 16x cubed with respect to x plus antiderivatives of 2x with respect to x plus antiderivatives of 6 with respect to x. Then, okay, write the coefficient before the integral symbol. That will become 10 antiderivatives of x raised to 4 with respect to x minus 16 antiderivatives of x cubed with respect to x plus 2 antiderivatives of x with respect to x plus 6 antiderivatives of dx. So we write the coefficient before the integral symbol. Then simplify. Apply now the antiderivative rules. So this is 4 plus 1, and that will become 10x raised to 5 over 5 minus 16x. So this is cube, and that will become 4 over 4 plus 2. The exponent of x is 1 plus 1. So we have x squared over 2 plus 6x plus c. So antiderivatives of dx is x plus c. So we add 1 to the exponent, 4 will become 5, 3 become 4, 1 become 2, becomes, okay, then that 5, divide also by 5, divide also 4, to here, divide also by 2. Then simplify. Then divided by 5, we have 2. So we have 2x raised to 5 minus 16 divided by 4, 4x raised to 4 plus 2 divided by 2, x squared plus 6x plus c. And that will be the answer. 2x raised to 5 minus 4x raised to 4 plus x squared plus 6x plus c. Number 4. Antiderivatives of 5x cubed minus 4x squared minus 3x plus 2. Okay. Distribute the integral symbol. That will become integral of 5x cubed with respect to x minus integral of 4x squared with respect to x minus integral of 3x with respect to x plus integral of 2 dx. Kapag may coefficient, pwedeng ilabas. That will become 5 integral of x cubed with respect to x minus 4 integral of x squared with respect to x minus 3 integral of x with respect to x plus 2 integral of dx. Okay, then apply now the integral rules or rules in antiderivatives. So 5x, 3 plus 1, that is 4. So this will become x raised to 4 over 4 minus 4 squared, that will become x cubed over 3 minus 3x squared over 2 plus 2x plus c. So 3 become 4, 2 becomes 3, 1 becomes 2, and divide each term by the exponent. So 4, 4, 3, 3, 2, 2. So here 1, 1. Okay. Then simplify. If we can simplify, so 5 over 4, that is now the simplest form. 4 over 3, simplest. 3 over 2 is also simplest form. So this is now the final answer. For number 5, okay. For number 5, what is the antiderivatives of 6 over x cubed plus 6 over x squared plus 5 over x plus 3? Okay. So this is equivalent to antiderivatives of 6 times 1 over x cubed, or we can write the x cubed as negative exponent, and this will become 6x raised to negative 3 plus 6x raised to negative 2 plus 5 over x plus 3. So we write 6 over x cubed into negative exponent, which is 6x raised to negative 3, x squared, x raised to negative 2. So that is the negative law of exponent. Then, since we have a coefficient, we write that coefficient, I know, distribute first the integral symbol. So this will become integral of 6x raised to negative 3 with respect to x plus antiderivatives of 6x raised to negative 2 plus antiderivatives of 5 over x plus antiderivatives of 3 with respect to x. Ala, I forgot the dx. Okay. Since we have a coefficient, we can write that coefficient outside the integral symbol. So we have 6 integral of x raised to negative 3 with respect to x plus 6 integral of x raised to negative 2 with respect to x plus, so 5, that will become 5 antiderivatives of 1 over x with respect to x plus 3 antiderivatives of dx. Then apply now the antiderivatives rule. So we have 6x raised to negative 3 plus 1, and that is negative 2. Divide also by negative 2 plus 6x raised to negative 2 plus 1, that will become negative 1 over negative 1 plus 5. Integral of 1 over x is ln of x plus 3. Integral of dx is x plus c. Then simplify. So 6 over negative 2, that is negative 3, x raised to negative 2 plus 6 divided by negative 1, that is negative 6, x raised to negative 1 plus 5 ln of x plus 3x plus c. So, okay, so x raised to negative 2 right now into positive. So right now, in the denominator, to make that negative exponent positive, so that will become negative 3 over x raised to negative 2 plus, sorry, minus 6 over x plus 5 ln of x plus 3x plus c. Okay, that's the answer. So that's the way how are you going to find the antiderivatives of polynomial function using these rules. So I hope you understand. God bless to everyone.